Okay. All right, welcome everyone, and good afternoon, or perhaps good evening is more correct. I appreciate all of you coming to join us for this plenary session on on-orbit servicing and refueling. As you can see, we have a large group of distinguished panelists, and I will introduce them in just a moment. And we will try to stay within the time frame that was allocated to try to get everybody out of here at a reasonable hour. The organizers would like to make sure everyone's aware that there are tablets of paper available for questions. So if you have a question, raise your hand, and they'll bring one of the tablets up to you, and we'll be able to ask the question. The format for this evening, I'm going to introduce the panelists, and then each will have a very brief presentation, 2 or 3 minutes, tell you about their technology and what they're doing, and then we'll go to Q&A after that, questions from the audience, and we have a few prepared questions as well. So I'm this guy, I'm Tony Colucci from SSL, and why don't we get started? It seems to me that we're standing on the threshold of a transition to a new era in space, and I'm sure you've been hearing that all day. I think we're looking at an era in which on-orbit servicing will enable entirely new space architectures. The people participating in this plenary represent organizations that are driving this transformation to new capabilities on orbit and to extending the value of existing infrastructure. It's kind of odd, but there isn't any other expensive infrastructure in the world that isn't serviceable or repairable. I mean, think about it for a moment. If your car ran out of gas, would you throw it away? If the front door on your home got stuck and wouldn't open, would you abandon the home? Of course not. But this is what we do with space infrastructure. So we're now looking at an era in which robotic servicing and maneuvering of satellites in orbit, assembly in orbit with standardized elements, low-cost, high-volume delivery on orbit is going to enable us to really take a new look at the way we manage these expensive space assets. And within a few years, of course, will transition us into a new era of how we use those assets. And in fact, I think the sheer number of our distinguished participants on this plenary is evidence of the transition that's taking place as we speak. So let me introduce them. Do we have the next slide? Well, I'll do it without that. Beginning from the end. Oh, perfect. There we go. Shahida Barak, Effective Space Solutions. Effective Space offers life extension and in-orbit service for GEO satellites, and is deploying a fleet of small spacecraft with using a universal docking system. Shahida has a degree in aeronautical engineering from Queen Mary College, and prior to joining Effective Space, she spent 13 years with Airbus in both commercial and military satellite communications. She was the only female operations director on the British military launch campaigns, and she participated in 8 of those campaigns. Next to Shahida is Robert Feuerbach. There's Robert. Robert is with Space Infrastructure Services. SIS will inspect, repair, refuel, relocate, and service satellites in geostationary orbit. It's majority owned by Finance Technology Leverage, which is a Silicon Valley investment company, and the company I work for, SSL MDA Holdings, has a minority stake in the company. Robert has a degree in computer science and an MBA. And prior to joining SIS, he held executive positions with EchoStar, SES, Hughes Network Systems, Eutelsat, and SpaceX, basically all of the interesting entrepreneurial space companies. Next to Robert, Michel Frazet with Airbus Defence and Space. Airbus's on-orbit servicing division plans to provide servicing and refueling also to geostationary satellites. Michel has an advanced degree in systems control. He began his career at Matra Space, where he worked on guidance and control for Rendezvous on the Hermé and ATV programs. And he has led excuse me, Airbus's on-orbit servicing division since it was formed in 2015. Next, Jörg Kreisel with intelligent building blocks for on-orbit satellite servicing. IBOS Consortium is developing a standardized multifunctional interface and a standard functional building blocks under funding from Germany's DLR Space Administration. IBOS GmbH is the commercialization entity that's bringing these standards into use for hardware coupling, servicing, and component replacement. Jorg holds a degree in aerospace engineering. He's a graduate of the International Space University. He's a lecturer, entrepreneur, venture capitalist, and board member of high-tech startups and investment vehicles. And he doesn't look it, but he's been involved in commercial space around the world for 30 years. Next, Paul Sheridan with Optus Satellite. Optus currently operates a fleet of 5 geostationary satellites that provide all satellite TV broadcasting here in Australia and in New Zealand. They also provide satellite communication services for the Australian Defence Forces, and they operate the NBN fleet. Paul himself has more than 30 years' experience in satellites. He was involved in the development of the Australian National Satellite Network, AUSAT, which is today Optus, and he's been responsible for Optus satellite business since 2009. Pete Swan with the International Space Elevator Consortium. ISEC is working on development, construction, operation of space elevator infrastructure for revolutionary and efficient access to space for all types of missions. Pete has more than 45 years' experience in space systems engineering. He holds a PhD from UCLA in space tethers and their dynamics, and he's published numerous papers and studies. And finally, last but not least, Tom Wilson, Space Logistics LLC. Space Logistics is a subsidiary of Orbital ATK. It offers mission extension services, which include station keeping, inclination reduction, and inspection for geosatellites, and they plan to launch their first spacecraft next year. Tom's the president of Space Logistics, and he's vice president of strategy and business development in Orbital ATK's Space Systems Group. He has extensive experience in both commercial and government space, having worked at Swales Aerospace and in the U.S. Department of Defense prior to Orbital. So please join me in welcoming our panelists. All right, as I said, the format is simple. We'll have a brief introduction and overview from each panelist, and then we'll go to Q&A, and we'll simply move left to right. So Shahida, if you'll start, please.
Hello, everyone. Firstly, I'd like to thank the IAC for inviting me to be a panel member. Secondly, I'd like to say I'm looking forward to learning a thing or two from my fellow panelists today. And thirdly, I'd like to say thank you to all of you for coming to this late plenary. I hope we can make it enjoyable and educational for you all. So before I present a short video on what Effective Space is about to offer to industry, I'd just like to add to what Tony said about Effective Space, just to set the context. So the company was founded little under 4 years ago in Israel. As of last year, it's a registered UK company, and I am their very first full-time UK employee. So I have moved over from the corporate world into the startup world, and it's actually very scary. So what is the ambition for Effective Space? The ambition is to become the service provider to satellite operators seeking in-orbit services. Life extension is one such service, and there are plenty more which we will try to describe through the course of this session. The mission is to procure, launch, and successfully rendezvous and dock with any geostationary satellite in the operational belt, and following successful docking to provide operations in orbit services. So before I run the video, I would just like to say that along with the companies here today, some of whom no doubt have already signed contracts or perhaps are about to sign contracts with operators, I think it's important to say Effective Space is on the verge of signing our first contract to deliver life extension to not just one satellite, but to 2. And personally, I think this is a fantastic achievement for a company that's only 3.5 years old, with a workforce of about 30 people, including myself. So without any further delay, I'd like to play the video. So in lieu of my voice, you will be subjected to cheesy lounge music, for which I apologize in advance. So let's see if this works.
Just do one click and see if they hear it.
And again.
Okay, thank you, Sheeta. That was perfect. Next is Robert Feuerbach with SIS. Robert, the controller is there, and we'll compress you down to 2 minutes and 50 seconds.
Well, thank you very much for having me here on this panel as well, and I'm very pleased to have so many companies here present today. I think practically everyone that's active in this space here today. So it's a real treat for me as well to have you all here. I'd like to talk a little bit about what we are doing in our space. Let's see if this works. There you go. So Space Infrastructure Services is a new company that's been formed with a minority investment of SSL, as Tony mentioned, and a majority investment from an investment company in the Palo Alto area. It really will be the world's first fully featured robotic service spacecraft that will be available in 2021. And when I say full featured, providing a plethora of services with 2 robotic arms. As you can tell, the spacecraft is going to have roughly close to 4 tons of available propellant for delivery to different clients. And 10 megabit data link and mission life of about 15 years. So we'll be able to perform several different missions for our customers per year. We've assembled a who's who of the robotic, space robotic community as part of our partners. And basically our service arrives when a customer needs a mission. Obviously we like to pre-plan these missions, but we can also do remedial missions on very short notice. Conduct the mission. After a few days, we perform what we have to do and leave for the next mission after that. So Our idea is that we're providing now, and I think several members of this panel will be providing the industry now with a new way of thinking of managing your CapEx, and when you deploy it, and when you decide to buy a satellite, or if you decide to buy a satellite for a few years later, through the availability of these kind of services. Does it work? There we go. Oops. I hope Brett doesn't, yeah, okay. Now, in terms of our partners, we have SSL, of course, on the bus side, the satellite platform, one of the most used platforms in the world, very well proven. MDA has been involved in countless space robotics missions. In fact, close to 200 plus missions in space already, with a total of 30 years of in-orbit servicing capability proven already in space. And the other partners for that are DARPA, which obviously is always pushing the limits on space designs and space hardware. The U.S. Naval Research Laboratory, which will be providing the actual arm and the software for that, but we'll be providing the arm right underneath them from MDA. And Draper, that does RPO, it's one of the best companies for RPO as well. So if you look at what we've done in the past, we've been involved in 91 missions for the space shuttle. We've been involved with close to 18 years now, the ISS, on weekly operations. We're involving the two robotic arms we have, the Canadarm2 and the Dexter manipulator. Every single lander and rover that's gone to Mars has had our arms as well, and they're still operating. So one of them is operating close to 15 years now. So I think we know robotic arms very, very well, even those that are not, in close proximity to the Earth. And of course, this brings then a partnership of companies that we believe is very, very unique in this space. So we believe that in 2021, and with the advent of other players here as well, on-orbit servicing really changes things dramatically. It changes everything, in fact. It changes the way satellite operators think of satellites. It changes in the way satellite operators will also think of infrastructure buildup in space now that was not possible before. And by that I mean replacement of components or buildup of components later on. You don't have to think 15 years down the road anymore. So a big change, a paradigm shift in the way that we've been seeing the industry. But rather than talking here for the next minute or two, I want to show you a short video of a mission that we performed with NASA. This is a video that's available on YouTube, but this is an abridged version of that shows a refuel operation we conducted on the ISS in 2013. And this is the basis of which we're also building up our hardware and our software now for the commercial mission that we're launching in 2021. So here it comes.
These days, one word drives high-tech: creativity. If nothing else, NASA's robotic refueling mission, RRM, is creativity embodied. And like all things creative, it's not without challenges. Satellites are machines, and like all machines, fuel runs low, parts wear out. RRM set out to prove that robots could repair them in space without placing an astronaut at risk. It's really hard to do, full of challenging problems.
Any problem is a solvable problem.
And repairing satellites in space is not a new problem to solve. Complex machines, satellites are neither easily built nor replaced. Refueling and repairing them in space just makes sense. As NASA prepared to launch the final space shuttle, the Satellite Servicing Capabilities Office pressed forward with an idea, a test, designed to see if robot technology was up to the job. In 18 months, the team designed the essential RRM experiments, getting hardware built, launched, and installed on the International Space Station.
We had the very aggressive schedule to launch in 2011 to make it on the last shuttle flight, which we succeeded in doing.
So we always say here that we want to test as we fly. We want to test, and test again.
They did, the team completed a series of delicate maneuvers, custom robotic tools, standing in for astronaut fingers. RRM's to-do list looked easy. Unscrew this, cut that, refill a tank like pulling up to the low-octane pump. Right? No, not easy at all. And that's the thing about missions like this. They demand the best from teams, and people don't get on the team unless they're willing to bring their A game. The team put 3 years of planning to work. With ethanol streaming into a tank on orbit, engineers watched the data stream back to Earth. Simulated fuel transferred, the team moved to detach the valve. Whoa. Real experiments often yield interesting results.
I don't think anybody expected it would stay liquid that long.
But after so much hard work, some things are just to be expected. NASA's reasons for doing this work go beyond the obvious. In fact, the deeper value for the nation is ingenious. This work helps open the door to a whole new kind of aerospace business. Big business. Engineering in space. Inventive. Daring. Smart. And RRM delivered them all. But the big picture? There's only one word that will suffice. Creative.
If you think RRM was incredible, I mean, you guys haven't seen anything yet.
All right, very good, Robert. Thank you so much. Next, Michelle with Airbus will talk a little bit about their program.
Good afternoon, ladies and gentlemen. Thank you very much, Tony, for having been invited here and having the honor and pleasure to present the Airbus Defence and Space Tug. So before any words explaining, I suggest you to embark on the Space Tug. We are beginning of 2022 in geostationary orbit. So what is behind this geostationary application of the Space Tug? This is a global vision where we intend the Space Tug to be a game changer in the space logistics and also in the on-orbit services. So the basic idea is to move from the left, where you have one single launcher, one dedicated orbit, and the satellite with its lifetime, to move to introduce flexibility. So flexibility in after the launcher, flexibility to place the satellite on orbit, and finally, to get the locally on-orbit services, ranging from refueling, life extension, payload delivery, inspection, and also surveillance with the vision-based navigation. So what we call a three-loop concept with this flexibility introduced during the various levels being in orbit. So now, what is our roadmap to realize this? So the roadmap is based on a few key words. First word is product line. We have learned since years that the best way to be on time and on cost is to reuse a lot of common elements in a product line. So on the left, we based our value proposition on ATV heritage, where we had 5 successful missions to ISS, the heritage of numerous platforms, including Eurostar 3000, and the electric propulsion heritage. You have certainly heard that actually there is one Eurostar 3000 doing electric orbit racing to the geostationary orbit. And finally, our robotic heritage in our Bremen robotic laboratory. With this product line, we intend to serve 4 basic applications, one in geo-servicing, one for debris removal, notably in LEO or for OneWeb constellation, and the application for space logistics, for satellite delivery and exploration. And those services can be classified in one with existing technology, around 10 kilowatt version, onboard power, and the second batch with 60 plus kilowatts to get advantage of the electric propulsion with higher propulsion on board and higher electric propulsion engines. And clearly, the first application we are targeting is where the market is, as our colleagues, in geostationary servicing, targeting a launch end of 2021 with a beginning of service in early 22. The key services that we intend to provide are everything related to life extension, including, of course, refueling, inclination correction, repositioning, graveyard, everything related to those maneuvers in orbit, surveillance with the embarked vision-based navigation, and payload exchange that is, again, not science fiction, because there was a call for tender last year for an operator asking to have manipulation of a payload once satellite is in orbit, later on 2 or 3 years later. And our, say, space tug for geostationary orbit will be based on the use, a lot of off-the-shelf reuse, notably for the platform. You see here with green is reuse, the orange is for the robotic part, and blue is dedicated to the refueling. So this is a picture that our manager liked very much because you see the amount of reuse in it. So this is what we are targeting now, looking for completing our partners' portfolio as well as looking for a customer. Thank you very much.
Thank you, Michel. So your challenge is going to be to fit in 2.5 minutes.
Okay, good afternoon, everybody. I also brought a video, but that doesn't have an audio track, so I'm going to sing for it. Anyway, so you see different names here. I'm carrying 2 hats. We've been working on the on orbit servicing activities together on concomitant activities with DLR, JAXA, and CSA in 2000 through 2007. And I've been involved with companies like Orbital Recovery and a couple other activities along the lines. So you see a logo here that was very prominent about 10, 15 years ago, OOS, on orbit servicing. What I'm trying to, does it move? Trying to say, okay, so something went wrong here with the presentation, so count on the video. On orbit servicing is not one solution to this, and I will address a side of it which is passive on orbit servicing. So design and technologies enabling all the stuff we discuss here. And as it was mentioned earlier, it's about on orbit servicing will change almost everything, and not only the design and managing CapEx, but also the commercial equation for everybody, all of the stakeholders across the board, from manufacturers, service providers, and satellite operators. Yeah, so this is the company IBOS, which has been, is the commercialization entity of an activity which is in Germany, funded by DLR and the German Federal Ministry of Economics and Technology. And IBOS, you will see a short video, deals with the passive side of an orbit servicing. The little image you see here shows the core. On the long run, out there is LEGO in space, and we want to work in this direction via USB in space and enabling technologies. The core elements are standardized multifunctional interface with fail-safe system on the right-hand side, combining mechanical, data power, and thermal interface, and standardized building blocks. These are the things here on the left. So what is this good for? It's good for all the things which have already been mentioned and will be mentioned by other panelists here. We're working through modular systems which enable enhanced flexibility, exploration, orbital systems, debris removal was addressed. It partly uses the same technology on orbit assembly and orbit manufacturing, and you name it. Warehousing is for logistics concepts and these type of things. What's one? Okay, so that's the vision. I just said that. I will skip this slide. So basically moving from interfaces, enabling, combining, extending, coupling any space, any modularized concepts and for any type of in-orbit infrastructure elements. So I hope this video starts. So IBOS stands for Intelligent Building Blocks for On-Orbit Satellite Servicing and Assembly, and the background and the motivations are pretty much the same. For all the players who address this, is we want to go for run away from one-of-a-kind satellites, enable for space sustainability, and here's a visionary picture, and we believe that IBOS technology can be a key to such on-orbit servicing infrastructure in the long run. On the left-hand side, you see where the vision may be. Here is the core element. On the left-hand side, standard building blocks with some intelligence and distributed power, computing systems. Here is the standard interface, as I mentioned. It's a quite smart system. As I said, it combines several functionalities. Here you see the thing in action. The ring around it is a thermal interface, and it's a patented system. Here is the building blocks, which comprise distributed computing power and control units and thermal interface, and can accommodate any type of subsystems and components. The vision on the business side foresees sort of an open source thing where to an app store type system, everybody in the world is invited to contribute. And here you see how this works. If we would build a satellite totally comprised of these IBOS elements, it would go like this. We have an integrated design tool which helps you click together all the elements you need, and then from an endless number of configurations, it figures the optimum one depending on the fairing or payload, and then that can be transferred into a virtual test bed to test the satellite straight away in orbit with all the parameters you want to understand. So that is the story of IBOS, and here's a little impression of full simulation of a satellite being serviced in orbit. So that's not a video, that's a fully designed satellite and simulation, and it gives you a bit of an idea. So you can look into and document all the parameters and go into all the details. So here's a satellite that goes for some Earth observation activities, and here a particular unit is being exchanged by a service or docking to the satellite. And then these are things which, of course, everybody dealing with this understands. Here's a bit of the story. The German government backs it for a long time. The consortium of a couple of renowned institutions on top. We have the IBOS GmbH is our company that commercializes and licenses this, and we have a solutions company that helps and provides engineering services for any scaling, up and down scaling of elements, etc. So that is the story of IBOS. And just to conclude this, here is a kind of a near-term impression. You may understand that some rather logical or first step immediate applications can be a standalone solution for this standard interface in various facets, as well as hosted payload adapters or a universal experience box providing standardized access to in-orbit microgravity experiments and these types of things, or as you see on the right-hand side, any coupling, extension or combination of space infrastructure elements. And yeah, that is the end of my little tale. Thank you.
Thank you, Jörg. So since we have a panel of people who have interesting technologies and ideas they want to sell, I thought it might make sense to have at least somebody up here to keep us honest, who's the guy to whom we're all trying to sell this stuff. So Paul Sheridan from Optus, take a minute and talk to us about how you might use some of this stuff.
Thanks, Tony, and thanks to for the opportunity to come and talk. having been involved in the industry for over 30 years, I'm very, very proud of what has been put on here in Adelaide, in our home country. So a credit to all those involved in pulling this together. As you may have worked out, I'm the token operator on this panel. Interesting in some of the videos, a big comment about the thing that primarily causes us to deorbit satellites is that they run out of fuel, but none of the satellites that we have the fuel gauge on them as yet. So it's all done by bookkeeping. It's one of the things that we have to be very particular about. Who are Optus Satellite? We're Australia's leading satellite operator. We've been in operation for over 32 years now. We've had 10 successful geostationary launches, and we currently have 5 satellites in operation. As you can see on the chart there, the 5 with the boxes are the ones that are still in operation. And if you look in between, say, if you can see your Optus D1, D2 and D3, which is the 2nd, 3rd and 4th boxes, and look at their launch dates, you'll notice that it was 2006, 2007 and 2009. As we get towards the end of life of these satellites, which is 15 plus years, all the comments that the previous panellists have said about managing your capex and looking at how you extend life or manage the life of satellites as they come to an end will be very top of mind for us in the next few years. I don't see it as the end of manufacturing or launching new satellites, because things actually happen during the 15 years on orbit, but to be able to potentially attach a life extension vehicle to deal with an issue that might be happening in your build program, in your replacement program on the ground, or if there's an issue with getting to orbit via available rockets to replenish your fleet. This is where flying fuel tanks or flying extension vehicles on orbit would become very valuable to an operator. It gives us a number of options. It's not only we're going to run out of fuel at this date, so critical for our customers. If there's options and opportunities to look at potentially a 3-month extension, a 6-month extension, or perhaps to splash some fuel into a satellite that has had a very, very healthy life and is still fully operational, they're the sort of things that, as an operator, we would consider on the matrix of opportunities to build, replace and manage your satellite fleet going forward. So some very, very exciting things that are happening on the manufacturing side and the life extension side. So I just have one more slide, which just gives you a bit of an insight into what our network in Australia is here. We've got 3 primary earth stations across the landmass of Australia. We're part of the Tier 1 telco, Optus Communications, which some of you will have be aware is on your mobile phone as the operator that you chose when you came into Adelaide. Tier 1 telco with 10,000 people. We have 140 dedicated satellite people. Every day they get out of bed and all they think about is satellite operations. We're in Sydney, which is the Belrose Earth Station, our primary facility. We have Perth on the western side, Lockridge. You can see that there's antennas facing east and west, so we operate into the Indian Ocean, and satellite dishes that you can see this side are our national satellite dishes, and then we have a facility down at Oxford Falls and one in Canberra, all linked up by fibre to provide primarily broadcast operation services for the TV industry. We also do other things like two-way data. We do launch support, which is something we're very proud of. We're up to almost 100 launch supports for other satellite operators out of our facility in Belrose. And as I said, we've got 140 dedicated people who we look to nurture. We've got there's opportunities for people to come and work for us and get involved in space without disappearing to other parts of the world. So again, thanks for the opportunity to be on this panel. Cheers.
Thank you, Paul.
Yeah,
I want to thank the IAC and Tony Colucci especially on this panel, because this panel sees the future. There's no doubt about it. It's going to happen in the very near future. However, I'm here to talk to you about the revolutionary future that might not be quite in the next few years. But I don't want to stand up here and say that space elevators will happen. I don't think anybody can say that. But I can say that if it does happen, the revolution will be amazing. Think of it this way. These people are designing to go up to geosynchronous, refuel, repair, et cetera, et cetera. What happens if you could do that for $100 a kilogram daily, 14 metric tons per day, a week to get to geo, and no launch stress? Think of what you would redesign on your satellites. I mean, the change would be remarkable. And so what we're talking about in the space elevator community is, what will the future really look like? And so how did we get there? Well, the International Academy of Astronautics just finished a study, 40 space professionals, 5 years. They came to the conclusion that space elevators seem feasible. Those rocket scientists wouldn't stand up and say it will be, but at least they said it seems feasible. Then the International Space Elevator Consortium has completed 6 studies. We've taken each little topic of an area and looked at it for a year with experts, and we're looking at the problem. It still seems like the space elevator could happen. So if it does happen, I'm an old professor, I can't sit there and just stay still here. If it does happen, went one too far here. Let's see if it'll go. There we go. We see a combination of both a technological infrastructure to deliver product and also an enterprise, a business enterprise. The technological infrastructure for delivering product to geosynchronous and beyond, to the Mars gate where you release and it goes to Mars free of charge, no fuel required, or the moon, and then all the enterprises that would come along. The key is we're talking about the geosynchronous orbit right now. What happens if you can get there for $100 a kilogram? You're talking about a tremendous change in capability there. Not only refueling, but everything else. So that's what we offer for space elevators, a revolutionary future, but I'm really pleased to be here because these guys are going to start it and I'm going to take it from there. Thank you.
Thank you, Pete. So let me just say that we're happy to have Tom Wilson to join us. He is the one closest to launch. He's got his first spacecraft going up next year, so he's going to keep us honest.
In the next year, that's right. So good afternoon, everybody. Thank you for hanging out with us till the end here, or almost the end. So a little bit about Space Logistics LLC. It's a wholly owned subsidiary of Orbital ATK that, while Orbital ATK is focused on manufacturing the satellites and the systems that we're going to use for both life extension and on-orbit satellite servicing in general, we're off working with the customers, the clients, the investors, and the other satellite manufacturers that we're going to need to be partners with in order to be able to make these missions a reality. We've been at this as ATK and Orbital Sciences prior to the merger for about 6 years now. It's been an interesting road to get to where we are today. And then we sort of had the break finally in 2016 when we signed Intelsat for our first contract. What really enabled that is a combination of the docking technology that we've been developing over the past 5 years, proving that that was going to work, combined with the heritage in the GeoStar 3 commercial geosynchronous communications platform that we've got at Orbital, as well as the Cygnus missions, the rendezvous and docking technology from Cygnus, combined with other programs that we have in GEO that we do rendezvous and proximity operations. So we've got a number of different technologies that we're bringing together to make these missions a reality. We're starting with life extension as the first mission that we're going to perform with something called a mission extension vehicle. I don't have a video here to show you, but you can Google that, and it's on YouTube under Mission Extension Vehicle or Space Logistics LLC. As I mentioned, we signed a contract with Intelsat for docked life extension. Starting in the second quarter of 2019 is when we're targeting to start that service. We don't do refueling, we do dock life extension, so we rendezvous and attach ourselves to the back end of the satellite, sort of like a jetpack. We stay attached for as long as the client needs. Our satellite itself will do up to 16 years of life extension and other services, relocation, inspection. When we need to, we undock, or we can take a satellite and deploy it or drop it off in the graveyard orbit or wherever it wants to be dropped off. And then we go on to our next client, and we'll do that a number of different times over a period of about 16 years. The program started in April, building the first mission extension vehicle. It took a while to get our launch co-passenger identified. We can launch this satellite with another satellite on top of it. That's part of the economics of the business case, is that we can have a co-passenger. We signed our launch contract. Most recently, we completed our critical design review, made a lot of progress on the design development of the system. We've got 75% of the hardware in-house, and we're now off on integration. Been spending a lot of time on the regulatory framework to be able to do this type of mission. It doesn't exist today. There's not a mission license to be able to do this. The good news is we're doing it cooperatively, so a lot of cooperation is happening both with our clients as well as our government agencies in terms of how they're going to keep tabs on us, how they're going to keep track of what we're up to. And we've worked that out pretty extensively with the U.S. government, a number of different licenses we've received recently. I'm also proud to say we've got insurance. So the insurance community has reviewed extensively our system and has ensured not only our satellite, but the rendezvous and docking with our client satellites. That's a big first for the industry. In terms of our systems, we've fully developed the docking technology. We've tested it. We're in manufacture of the flight system. We've also spent a lot of time on electrostatic discharge technology. That's a key safety feature that we're all going to need to have some part of here in the future. We've tested all this in our rendezvous proximity operations and docking laboratory in Dulles, Virginia. We've been using this laboratory for the better part of 5 years to develop and test that technology. And now we're starting to develop and test the next generation technology. We're working on a next generation life extension system that will improve on the designs of the mission extension vehicle. We should have our second contract signed by the end of this year. And now we're starting to work on advanced technologies in the form of on-orbit assembly, working with NASA Langley and other key partners at NASA, and also tug-type services from LEO out to deep space orbits. So a lot of technology development, a lot of fun happening at Orbital ATK, and we should be launching December of next year.
Thank you, Tom. So we're a couple of minutes past the nominal ending time, but since we started late, we'll continue and do a few questions. Maybe we'll go until about 7 o'clock or so, about another 10 minutes. So we have some good questions from the audience. Again, a reminder, if you have a question, put your hand up, and one of the stewards will bring you a question sheet. So let me start with the first one, and this one is to Michelle. In the future, beside refueling, what can we expect? Payload servicing, payload replacing, etc.
So today, indeed, provided that you have the capability to do rendezvous and proximity operations and having the robotic arm to do the refueling, it's basically, between brackets, question of tooling and to have anticipation to the payload itself, to be capable, once docked, to plug, between brackets, the payload. So this is exactly the scenario that we have analyzed for a potential customer, operator. Today, there is no decision on the follow-on of this proposal, but what we know is this solution is technically credible, again, relying on the other elements of your satellite as described by my colleagues, capable of docking and having a robotic arm to do operations.
Robert, I think you've talked about, in addition to possibly doing replacement and so forth, you've talked about the possibility of some kind of repair work, something like that?
Yeah, in fact, this is in addition to what you're saying. The requirement, for example, on our particular satellite, on our servicer, to have 2 robotic arms came from DARPA. And we have 2 contracts, one with DARPA, one with SES, the largest satellite operator by revenue today. So the portion of refueling came from our side. DARPA required all the other maneuvers, and for that they required 2 robotic arms, all the different tool sets and the head end of the satellite system, so that you can go replace and get the tools you need for different kinds of operations, including assembly of larger structures that can't be launched on one single rocket, for example, very, very large structures in space, but also payload replacement and looking at future types of configurations of satellites where you may have plug-in modules externally. So, but the refueling part came from our side, so that we thought, offering 5 different services with the same vehicle made a lot of sense, in particular because the sitting duck market right now is, in fact, the satellites that are going out of service, and so some kind of life extension makes the most sense right now for those satellites that are up there. But the capabilities are much, much wider ranging than that, and so that's why we have 2 robotic arms.
Good, thank you. Shahid, a question for you. What happens to your spacecraft when it runs out of fuel?
Okay, so first of all, I stuck to 3 minutes and you guys didn't, so I should have said a lot more about my technology, and furthermore, I don't have the marketing budget that you guys do. So I think it's important to say something more about the effective space solution. We've talked a lot about fuel transfer and robotic arms and whatnot. The differentiator with effective space is that there is no fuel transfer and there is no intrusion of one spacecraft onto the other. It's a very passive docking system whereby 4 docking arms latch onto the launch interface ring, which is very resilient because it can withstand launch forces. So once attached, we act as a jetpack, take over the orbit function. So to answer the question, for those customer satellites, host satellites that are running out of fuel as part of contract negotiation, we will discuss whether they want effective space to act as a jetpack or whether they want us to take over the full orbit, the attitude control as well. In which case, we will manage every aspect, orbit, attitude, momentum, offloading. And that's all part of contract negotiation. And also, it allows the operator, it's everything my colleagues have discussed already. It gives that the most amount of flexibility to the operators. If they want to operate the last drop, they may do so. And it's basic orbital mechanics and satellite operations. If we can life extend a satellite, then we can move the satellite so they can operate to the very end. We can graveyard, we can reposition, we can inclination null, everything. The whole catalog is available.
And then what happens when your spacecraft runs out of fuel?
Well, we would detach prior to that, because I think that would be awful if we ran out of fuel and we were still attached. We would do all the calculations, and it's a joint activity with the customer and ourselves. And we would work out how many years life extension the customer wants, what kind of service they want, and that will then determine what we can offer them. And prior to that, we will detach, and when the time arrives, we will decommission our satellite.
Very good. Maybe this is a good one for Tom, since you're close to launching. The question is just to give a little overview of the technology you're going to use in the rendezvous and proximity operations.
Well, we have a number of different sensors that we use. We use 3 different sensor systems to do the rendezvous and proximity operations. Then, like I said, we developed in our laboratory a special docking mechanism. We call it a docking mechanism that goes into the apogee kick motor and deploys into the apogee kick motor and basically deploys on the other side of the throat of that apogee kick motor some fingers that we use to pull together, and then interface, and the load is carried through the launch adapter ring.
Perfect.
Pretty simple.
All right, well, I'm afraid we've run out of time, so once again, thanks to everybody for bearing with us at the late hour, and special thanks to the panelists for sharing their views with us. Thank you.